Okay, so hello everybody. We're going to be talking all about California's relationship with water today. We'll be talking about the history of our water, where we get it, how we use it, and different ways we can be more efficient with it. So I'm here with Michelle. My name is Gina, and we will get started. First, we have Michelle to talk about the history of our water.
Thank you, Gina. In the history of our water, we will be going over where we get our water and to some information on droughts. Go to the next slide. Yeah. First, we'll be going over some common types of water supply on the surface. Aqueducts are some artificial channels used to convey water, typically in the form of a bridge. And reservoirs are large natural or artificial lakes that are used as water supply. We can see in this picture in the middle that the reservoir is held up by a dam. Canals are artificial waterways constructed to convey water for similar uses. And although they're very similar, the main difference between aqueducts and canals would be that aqueducts are used to move water from one location to another, while canals often connect one body of water to another. Now that we learned about some of the surface water supply, we're going to have a pop quiz. So where do we get most of our water within California? Would it be A, surface water, which was the aqueducts, reservoirs, and canals, or B, snowpack, which is condensed snow from seasonal accumulation, or C, groundwater, which is water held underground within soil or rocks? If you could type the answer into the chat, that would be nice. We have a couple snowpacks here, B. Another B. Okay, so the answer is B, snowpack. I see a lot of people got that right, which is very nice. And snowpack stores about 65% of the water supply within California because it also replenishes the reservoirs and surface water supply in the warmer months. And although we do get 65% of our water within California from snowpack, over half of the total water supply comes from other states, such as from the Colorado River. California has always struggled with our water because we are definitely not new to this. The southern 2/3 of California has always been prone to drought conditions and dryness. This is because our aqueducts, canals, and reservoirs can be depleted, which leaves us very much dependent on water that is brought elsewhere from Northern California or from the Colorado River. And about 40% of the water supply comes from the groundwater, but during the dry seasons, this demand increases to 60%. This is because during the summers, there is naturally little to no precipitation. And when there is little rain or snow collecting, it becomes harder to reach the demands by surface water. So we can only turn to groundwater. In this graph here, which is titled Mix of Water Supply Sources Shifts in Dry and Wet Years, the y-axis shows the different water supplies from surface water on the top to other on the bottom. And the x-axis shows by million acre feet how much water is supplied from these sources. On the very bottom supply here, which is local groundwater, we can see that in the light blue bar, which is dry years, the demand is much higher because it is much greater than the dark blue bar, which is during the wet years. Continuing with our water struggles, our water fluctuates greatly every year. And this is because we have patterns of dry years, wet years, and occasional average years. with our average rainfall and collection varying for different reasons, such as La Nina and El Nino. These are some irregular weather patterns that sometimes occur in the Pacific Ocean, but they usually affect weather conditions all over the world. La Nina happens when the winds that push warm water west in the Pacific are much stronger than usual, which accumulates the warm waters near Indonesia and Australia. While this creates more rain than usual in these parts, this also means that other parts of the world, such as the Western American coasts, can experience droughts. During El Nino, this is an almost opposite weather condition, where very weak winds fail to push the warm waters west from the Pacific Ocean and cause more precipitation in areas near the western coast of the US, Central America, and South America. This means that there will be significantly less rain in Indonesia and Australia. In this graph here, we can see on the left, on the y-axis, it measures the precipitation in inches. And on the x-axis, there is a timeline. And we can see that our water fluctuates very greatly in irregular patterns. And in the parts where the water has recorded very much below average for a long period of time, that would be a statewide drought in gray. This image sums up La Nina and El Nino for us. We can see on La Nina, the warmth has gathered on the left of the Pacific Ocean, which means that there will be more water over there and precipitation. And in El Nino, the warmth gathers more over to the right, which means that we will experience more precipitation in the American coasts. Some previous droughts in California that I decided to cover were some prominent statewide droughts the last 50 years, which would be from 1976 to 1977, which is the driest period on record, and then 1987 to 1992, which is the second driest period on record, and from 2012 to 2016. We can see in this graph here titled The Average Annual Runoff and Precipitation for Historic Droughts. On the left y-axis being runoff measured in million acre feet, and on the right being precipitation being measured in inches. The average precipitation in California is about 21 inches, but we see in these graphs in the light blue bars that they are well below 20 inches. But in comparison, the runoff, which is the water being drained instead of being used, is very high. Moving on to our current drought, the drought information system catalogs the intensity of droughts to 5 different levels, from exceptional drought, or D4, being the most severe, then extreme drought, D3, severe drought, D2, all the way to moderate drought, then just abnormally dry. In California, 33.3% of all the land is under exceptional drought, or D4, while at least 85.7% is under extreme drought. The reason for this being was that this last winter was unusually dry, with low record precipitation over the last 12 months, which means that we will have less snowpack for us to rely on the warmer months. We can see in this graph here titled the percent of Western land in drought conditions. The x-axis of the table shows the timeline from 2000 to 2021 from left to right, and the y-axis represents the percentage of the area where we can see in the upper right corner of the Western United States that were or are under drought conditions. The darker the color, the more severe the drought is, and as we can see on the very right side near present day, the dark red color, which represents exceptional drought, peaks much higher than previous patterns, and we can expect that it will continue for a long period. We have some nice visuals up here of how serious this drought is. This is a Lake Oroville, a reservoir in Butte County of Northern California. And the riverbanks have receded quite a lot to reveal much of the riverbanks. And we can tell from the color of the water that it is very shallow compared to the deep blue from the 2019 picture on the left. And there is also much less green around this lake. So we can tell that the drought is quite severe. This picture shows former docks on Salton Seas Beach in Southern California in the Imperial and in Riverside counties. Where normally the boats would be stationed at the docks, we can see that there's not enough water for the docks to even be in water and for the boats to stay afloat. So this leads us to the question of how prepared is Orange County? Orange County, we are classified as D2, which is about middle in the classification, and we are comparably prepared for droughts than other regions. This is because we have had a lot of investments preparing us for droughts, such as reusing filtered wastewater or stockpiling water for future emergencies. About 75% of all our water needs are met through our groundwater basin, and the remaining 25% is supplied through imported suppliers, such as the Metropolitan Water District of Southern California. This organization, which was created in 1928 between 26 cities across Southern California, redistributes water from the Colorado River. And due to investments and advancements in preparation for droughts, the Metropolitan Storage reports to having about 13 times more water in its reservoirs than it did in the 1990s. And while all of this preparation and investments are good news, it is not to say that we are not affected by water shortages or the effects of droughts. Next is, why are droughts more common? Droughts are worsening with global warming. With warmer temperatures, this means that there will be more rain in the winters instead of snow, which means that there will be less snowpack for us to rely on in the warmer months. And excessive water evaporation from soil with the warm temperatures creates a positive feedback loop where dry soil causes deforestation and the exposed soil causes further evaporation of water in the soil, and so on. It also leads to altered atmospheric rivers, and atmospheric rivers are these long, narrow regions in the atmosphere, like rivers in the sky, which carry a lot of water vapor out of tropical regions. Atmospheric rivers are important because they help end dry years with occasional periods of very heavy rainfall. About 33 to 40% of our past droughts have ended due to these atmospheric river storms. Global warming causes extreme weather patterns, which means that these atmospheric river storms can become so powerful that they can cause landslides and flooding, but this also means that they may not appear for prolonged periods. As we can see in this graph here, the warmer purplish to reddish orange colors indicate where there is a high risk for droughts, while the cooler green-blue colors indicate low risk of droughts. Areas that are well known for being extremely cold are blue, but pretty much everywhere else without snow 356 days a year, we are at risk of drought by the end of this century. This visual here I thought was very interesting. It's titled The Early June Drought Conditions in the West, and it shows the drought conditions in Western states from 2021 to 2004. The timeline goes backwards with 2004 being at the bottom right and 2021 at the top left. This also uses the color patterns that we saw in the tables before, with the darker reddish colors being the most severe. And we do see some droughts in the past from 2015, 2014, 2013. We see lots of darker red. But in 2021, we have a strangely large amount of this reddish color, which is not a very good sign. Next, we will be moving on to California water usage with Gina.
All right, so thank you, Michelle. That was a really good overview of our water in California. And now we're going to be talking about how we use that water. So California splits its water use into 3 different sections, we have about 50% going to environmental water uses, which I will be talking about in the next slide what those are. And then we have about 40% going to farms or agriculture, and only 10% going to cities or urban areas. And all of this, keep in mind, is a very rough percentage. The use of water varies a lot by where we are in the state and also between wet and dry years. These numbers can change a lot. So environmental water, it is several different things that it includes, and one of them is water that is in protected rivers that are considered wild or scenic, so they're protected by the government. It also includes water that is needed to maintain our freshwater habitats across the state, as well as wildlife preserves, so wetlands as shown in this photo in wildlife preserves. And finally, it also includes water that is needed to support this baseline of water quality for us to use in other ways. For example, our California Delta needs a certain amount of water to flow through it so that it keeps the salty water from the Pacific Ocean from intruding and contaminating our water. And a lot of that water is then moved into farms or cities for different uses. So those are the different things of environmental water. And as I mentioned, it accounts for about 50% of our water in California. But this can change a lot because during dry years, which as we've seen happens pretty frequently in California, that 50% often decreases a lot as we are using more. It's more important for us to be using it in farms and cities than to be letting it use as it would naturally be in the environment. So that is something to keep in mind. The next two sections, agriculture and urban, is pretty self-explanatory, but actually something to note is that they have both been decreasing since 1995. We can see in this graph, which shows the lines of total water use, agricultural use, and urban use, along with the slope of the population increase over the years. And as you can see, both of those things have been slightly decreasing for a while. While agriculture has been decreasing due to some changes in irrigation methods or things that are making it more efficient, there are still a lot of issues surrounding our agriculture water use, which we're going to talk about in just a moment. And our urban water use, it's surprising that it's decreasing because our population, as you can see, has been increasing. So despite our population going up, we are using less water per person. So I have some numbers here on that. Our per capita urban water use was at 231 gallons per person per day in 1990, and then it fell to 180 in 2012, and then all the way down to 146 in 2015. That was because of certain drought-related conservation efforts. And since then, our use has rebounded a little bit because we were advertising that we had gotten out of that drought. But we never went up to where we were before the drought. So that is good. We did not go back up to where we were. We just increased a little bit. But yes, that is some good news there, is that our per capita use has actually been decreasing. Something also to note about our per capita use is that it obviously varies a lot based on where you live in the state. That's all a statewide average. In East Orange County, it is one of the highest per capita uses at 226, and this information is from 2020, while other parts of our county are much lower. For example, Anaheim is at 75 gallons per day, and Irvine Ranch Water District is at 70. So it just depends on where you live and what it is in the area that you are in. So that is something to note. And then here I have this graph that shows you kind of an overview here of the different water uses. We have environmental in blue, agriculture gray, and urban in orange. And as you can see, like I was saying, it varies a lot based on where you are in the state. For example, a lot of those protected rivers are in the north. So we have a lot of environmental water usage in the north, whereas the most use for urban water is in the San Francisco Bay Area and the South Coast where we live, since there are lots of cities and towns and population in that area. And on the right side, we can see the difference between a wet year, for example, 2006, and a dry year, which an example is 2014. And you can see that that use for environmental water, while it's normally really high at 62%, in 2014, in a really dry year, it had to be used for urban water use and agricultural water use. So that went down to 28%. So it varies a lot, and those percentages were the average of different years. And then the next graph we have for you is the water use by state. And you can see the little names of the states on the bottom. It goes from the West Coast to the East Coast. And if you look at this really big tall one on the left, that is us in California. So yes, California uses more water than any other state. But keep in mind, we are one of the biggest states. So that is natural that we use more water. And since we were talking about per capita earlier, we do not have the highest per capita of any state. That is actually Idaho, fun fact, at 184 gallons per day on average. So we don't use the most per person, but we do use the most overall. And you can see in this bar, the majority of that water is used up by this green color, which in the key shows is irrigation. So now we're going to be talking a little bit about this agricultural irrigation, which takes up a lot of our water. And agriculture irrigation is actually the largest use of fresh water in the world. And also in California, it takes up about 70% of our freshwater withdrawals. In the US, it is the second largest use, and that's because of thermoelectric power plants. They use it to cool the electricity generating equipment. However, sometimes that isn't included in the count of freshwater withdrawals, since that water is normally returned to where it came from. So it's not necessarily withdrawing it to use it. They just use it and then return it. So irrigation is a really large part of our water use. And that is because, as we can see on the right, we are a big state with a lot of farmland. So the green areas are our irrigated farmland, and the yellow areas are dry land farming and grazing lands. So as we can say, that takes up a lot of Central California, the breadbasket. We do a lot of farming here. And over 9 million acres of our land in California is irrigated. So that uses a lot of water, as you can imagine. And sadly, a lot of our current methods of irrigation lose a lot of the water that we use to evaporation and runoff. So we'll talk a little bit about some different irrigation methods now, but before we get into them, we have a little bit of a quiz to see if you guys can guess correctly. Which of these irrigation methods do you guys think would be the most efficient? And then I will explain what each of them are and what the answer is afterwards. But go ahead and put in the chat which one you think would be the most efficient, use the least amount of water, just based on the way they look. 2 and B, yes. So as you can imagine, that is the most efficient. The answer is 2. I agree, it looks like it uses the least amount of water. We don't even really see any water in that photo. And I will tell you just why that is now. So here are the 3 that we were looking at before. The one on the left is called surface irrigation. It's specifically flood irrigation. And surface irrigation is a really traditional type of irrigation. It's been used for a really long time, but it is still used today since it is cheap and low tech and easy to use. But as you can imagine, by the way it looks, it is not the most efficient irrigation method. It loses a lot of water to runoff, since it can just, drip off the field if we're putting a lot of water onto the field there. However, it doesn't lose as much water to evaporation as the one on the left, which is spray or sprinkler irrigation. Specifically, this one is the center pivot. So if you've gone through farmland and you've seen the dry area and then big circles of green, that's usually a center pivot irrigation system. And spray and sprinkler irrigation is a more modern type of irrigation, and it is used pretty widely today, and it is sometimes still inefficient, even though it is a more modern type of irrigation. It doesn't lose as much water to runoff as this surface irrigation would, but it loses a lot of water to evaporation. And if the wind is blowing, it can blow that water away from the crops. So it often loses a lot of water, actually up to 35% can be lost because of evaporation and winds. So both of these lose water for different reasons and are just not the most efficient way to be getting water to our crops. However, they are often more economical, because this last one that you guys recognize as most efficient, it is called drip irrigation. It's a type of micro irrigation, and it is more expensive and harder to install, and that is why it is not used as much. However, it is one of the most efficient irrigation methods. It uses, as you can see in the photo, hoses that go either underground or right on top of the soil, and it has holes in the hose that deliver little drips of water, like it's called drip irrigation. And in this way, they can target what plants they want to give water to, and also just give as much as needed to keep the soil moist and not too much. So it is really efficient, but it is hard to install since you have to have those hoses in the ground. But yes, that is kind of an overview of our different irrigation methods. There are many more, but these are sort of the basics. And that shows you the impact of irrigation in California. And next we have urban use. So that was a lot about agriculture, and now we'll talk a little bit about urban's impact, and specifically urbanization. So when we are expanding and our population is increasing, we're making more towns and more cities, we will remove lots of the plants and we replace it with buildings, parking lots, concrete, asphalt, all of that. And that is called impervious surfaces. And impervious surfaces means that the water can't soak through it. It will just run off of it. Another way that we're preventing that water from soaking into the ground is channelization of rivers and creeks. We do this a lot, especially in Southern California, where we'll artificially modify our rivers or streams with concrete riverbeds so that they flow a certain way and to protect from flooding. However, this prevents water from soaking into the riverbed and into other parts of the state and into groundwater. So because of all of these impervious surfaces and alterations to the environment, there are a lot of negative impacts. One of them is that we have more runoff. Since the water is not soaking into the ground once it gets there, it's going to run off through the streets, into the gutters, through the storm drains, things like that. So we have a lot more runoff that can be polluting the water system once it gets into it, based on different things that it collects on its way there through the city. It also causes more evaporation, since the water is sitting on the ground or running through it, so it does not soak into the ground and keep, it rather evaporates from the sunlight. And as I've been saying, the water does not infiltrate into the ground, so it's not able to go back to groundwater aquifers, where we have a section of this permeable ground that the water collects in. We are not able to replenish those aquifers because we have a lot of impervious surfaces covering our cities. Instead, it goes directly into storm drains and then into streams and through those to rivers and things like that. But this also can cause issues. It causes increased chance of floods, since the water is not being soaked into the ground, it is going straight into the streams. So a lot more water is going into the streams than would normally. So we can have, as you can see in this picture on the left, there's an increased chance of having floods in or near cities because of this. So that is urbanization's impact on the hydrologic cycle. And because of this, we have groundwater depletion. So as I was mentioning, we have underground aquifers. And you can see kind of an example of that on the left, on the right, sorry, where we have a well going into the underground aquifer to bring water up. And interestingly, 30% of our fresh water is groundwater. So a good percentage of the water that we can use is under the ground, and it is found in aquifers below the water table. And like I was saying, usually when it rains, this will naturally recharge aquifers at varying rates depending on where you are. And we can therefore continue using aquifers indefinitely as long as we are not taking out more than the rain is naturally putting back in. So we could have this sustainable source of groundwater as long as we are careful about it. However, we are often not super sustainable with our groundwater use, and we have to, especially in dry years, pump out a lot of groundwater. Like Michelle was saying, we have to rely on groundwater when we don't have that snowpack or rainfall replenishing our surface water. So we often have to rely on those underground aquifers and too much and a little bit more than the earth is naturally prepared to do. And some negative effects of depleting these aquifers is it can lower the water table. As you can see in this photo, this little blue line is called the water table. It's the highest point that the water comes up to. And if we're taking out a lot of water, it creates this little cone of depression, as it's called, where we are bringing the water level down. And if this goes down too far, then the well will not be able to reach the water, and we'll have to either just let it go dry and not have that well, or dig it even deeper, which increases costs, and also it costs more to pump water from deeper in the ground. So that can lead to it's harder to get water for us. Something else that depleting groundwater does is it actually reduces water in streams and lakes, which not a lot of people realize, but we have a lot of groundwater flow between our underground aquifers and up through the stream beds into surface water. And if we are taking a lot of water from a certain aquifer, as you can see in this photo, it can kind of interrupt the natural flow of that groundwater, and it can be taking water or not letting as much water as would usually go into surface water. Another thing that can happen is saltwater intrusion. And we have to think about this when we're on the coast like we are. If we have a well that is near to the ocean, it doesn't have to be right next to the ocean actually, because as you can see in this photo, the salt water goes under the ground as well next to the ocean. But if we have a well near the ocean and we are taking too much water from it, we can cause saltwater intrusion, where the saltwater can come up and contaminate the water that we are drinking, which is not good because then we cannot use that water. And finally, there's something called land subsidence. And land subsidence is basically when we take a lot of water out of an aquifer and the soil compacts because there's no longer water filling it up. And so because of that, the ground is slowly sinks. This happens over a long period of time, but it still happens very slowly. And it can cause a lot of issues with our infrastructure, and it can cost us a lot of money to rebuild things if the ground is sinking. And it also, once that ground has been compacted, there's really no way to fill it back up with water, so it can lead to permanent aquifer depletion, which is not ideal. Something on land subsidence, we have this picture here of somebody who took the photo in 1977, and it shows the estimated levels of where the ground was in 1925 and in 1955 up this telephone pole. So as you can see, it goes very slowly and not noticeably, but over decades, we can see the difference, and we know that this is happening. Kind of a shocking photo there, I thought. So because of all of this groundwater depletion, we are looking for a lot of other sources of water, trying to conserve and things like that. One thing that people have been turning to as a solution is desalination. However, desalination comes with a lot of issues itself. So one of those things is that it is really expensive. It is about double the cost of water from a new reservoir or recycling wastewater. And it's also 4 times the cost of just enforcing conservation methods, like installing drip irrigation or providing rebates for more efficient lawns and things like that in urban areas. So it is really expensive, and sometimes more expensive even than other solutions to finding our water. It also uses a lot of energy, which if you saw my presentation on energy earlier, we know that unless it's powered by renewable energy, it is going to be contributing to greenhouse gas emissions. So that is also a problem with desalination. Something that is talked about a lot with desalination, I think, is the harm to marine life. So because they are taking water straight from the ocean, they can actually be sucking in microscopic organisms in the ocean that cause a ripple through the food chain. So if those little tiny little things are being sucked in, then the bigger things that eat them don't get their food source, and on and on. It can also be sucking in little fish eggs and preventing those from hatching, and it can also just cause harm to the bigger marine life as well, since they're taking water straight from the ocean, which can cause a lot of issues. In addition, we have predicted a salinity increase throughout the years due to climate change. So along with the ocean waters rising, we have also predicted that salinity is going to be increasing. And if there's more salt in the water, it is harder to take out that salt in the water. That's why desalination plants often use brackish water, so water that is partially salt, partially fresh water with a lower concentration of salt. So it just costs more to be removing more salt out of the water. So the price would probably be increasing in the future. Another big thing about desalination is that once they have removed all that salt from the water, they are left with this sort of brine of any of the chemicals that they use to do that, or and all of the salt, and it's just this kind of like goopy mess of ickiness. And what they do is they return it to the ocean, since the ocean is saltwater, right? So you think that that would be fine. However, this can harm marine life because there's no dissolved oxygen in that brine, and there's also sometimes chemical residues. So a lot of that can, if it is deposited right near some marine life, it can cause harm to them. Finally, desalination can just perpetuate our water issues. This is what some people argue, is that instead of encouraging just conserving water and trying to find sustainable solutions, we're just turning to another thing and saying, where can we get more water? So instead of doing this, some people would advocate for just trying to establish first a sustainable way of using our water, and then we could maybe, if we still need, turn to other solutions. But those are some of the things about desalination that are not ideal. And something actually locally in Orange County, we have a Poseidon desalination plant in the works in Huntington Beach. It's been talked about for about 20 years, I believe. And on April 29th, 2020, it won a key permit. And it now just needs a permit from the State Coastal Commission before it can negotiate a final contract with the Orange County Water District. So just something to remind you of what's going on near you. There is actually a desalination plant in the works in Huntington Beach. So what are some good sustainable solutions to conserving water? I've talked a lot about the issues with our water use, and now I want to have a call to action about things that we can do as Californians, and then things that you can do specifically in your individual life. So things that California can do as a whole is having incentives for updating water systems. Often water providers will give rebates for people who are willing to change to update their technology, their appliances, as well as having more efficient landscaping. Also, there is something called tiered pricing, which has shown to work in other places where, it's shown to work pretty well, is that tiered pricing charges higher rates for people who use a lot more water. So it charges more as you go up in your water use. So that encourages people to conserve water, and that has been shown to work pretty well. Also, as California can have laws that will enforce reduction of water usage, we often have those in drought years, but once the drought is said to be over, we often release those more strict conservation laws. So something could be a more stringent one that is all the time and not just in a drought year. Something from earlier, we can have more efficient irrigation. So we can have that drip irrigation, which is more efficient than the sprinkler or the surface irrigation. Another thing that can be done on farms to help with the loss of water with irrigation is to level their fields so that the water will not run off through the little hills. And also we can capture and reuse that runoff. So that is some things that farms can do, since, as we mentioned, a lot of our water is used for agriculture, sorry. And Also, we can try to sustainably manage our aquifers. We can try not to overpump from them. And also there is something called artificial recharge where you can put water back into the aquifer to try to keep it as at the level that it is, even though we're taking a lot of water out of it. We can also, as shown in this picture, have less impervious surfaces in cities. We can have rain gardens, which take the water that would go into the storm runoff drains and use it for plants, and then it can soak into the ground, which is great. We can also install new storm drainage systems, which have recharge ponds, which do largely the same thing, where it lets the water soak into the ground. And we can also reuse our wastewater. We actually do a lot of that in Irvine, but that is something that can be used across the board, is reusing our wastewater. So those are some things that California can do as a whole. Now to some things that you can do individually in your life. The biggest thing you can do is actually to change your landscape watering, try to reduce that, because it is half of urban water use goes to watering our lawns and things like that. So one way you can do this is by planting drought tolerant natives. As you can see in this photo, we've got all of those nice native plants that are adjusted to this dry climate that we have. And so they're not going to need as much water, and they can actually be really beautiful. So that is a great option. Something else you can do is just make sure that your plumbing is up to date. And if you ever see any leaks, to try to address that immediately, just so that there's no water being lost that doesn't need to be. You can also have a lot of water saving appliances like low flow toilets or shower heads. And if you look in this upper left-hand corner, this is called the water sense marking, and you can find that on different appliances. It meets the EPA's specifications for water efficiency and performance, and it is backed by independent third-party certification. So that is something that you can know for sure, that your appliance is going to be more efficient than others. Products that have this label, they are about 20% more water efficient than average products in that category. And so you can know just when you're out buying things that that is something that will help. You can also support local initiatives to conserve water. And finally, just being conscious of your water use. This is really important, just as you go about your day, thinking about the fact that we are very prone to drought, and we should probably be careful not to just use water as much as we can, trying to be conscious about, when we're brushing our teeth or washing dishes, something like that, just knowing how much water you're using and trying to conserve it is great. So that is all of the information we have for you today. So thank you guys for coming and sharing your thoughts and listening, and have a wonderful day. Enjoy our Mediterranean climate. But yes, thank you guys for coming so much, and we will see you next time.